Great. Thank you, Jason, and thank you, Jessica. Our final speaker of the morning before we move to our panel discussion is Steve Henstra. Steve is a project manager and restoration biologist with Nature Trust BC. Steve leads the restoration, monitoring, and inventory team at Nature Trust, contributing to the management of conservation lands in the West Coast region of BC. He's involved in the design and implementation of ecological restoration projects, developing and implementing long-term monitoring and inventory projects, as well as community outreach. Steve is versed in both aquatic and terrestrial ecology, having completed his master's degree in botany from the University of British Columbia. And that combination of skills is a very strong asset when working in estuaries. In his free time, Steve's an avid hiker and camper and lives in Nanaimo on Vancouver Island. Welcome, Steve. Thanks for joining us.
Thanks. Thank you for that introduction, and it's great to be here to talk to you all today. The title of my talk today is Assessing and Enhancing Estuary Resilience to Sea Level Rise, Estuary Restoration in Action. So I'm going to be talking about the Estuary Resilience Project that we've been leading that John alluded to earlier, and just giving some examples of some of the work we've been doing under that project. So just a bit of project background. Most of us are well versed in what estuaries provide, but estuaries and coastal wetlands comprise less than 3% of British Columbia's coastline, yet they support over 80% of BC's coastal fish and wildlife. And since time immemorial, estuaries have been the location of complex food systems that provided abundance and wealth to Indigenous communities. And despite the ongoing deterioration of these areas over the last 150 years, estuaries continue to support 75% of all commercially and culturally important seafood in the Pacific Northwest, including, of course, salmon, clams, oysters, crabs, and forage fish. And, in terms of an Indigenous food system lens, these were often highly managed landscapes by Indigenous peoples, estuary root gardens, and food provision areas. The Nature Trust is a nonprofit land conservancy organization, and the Nature Trust and our partners have been involved in the securement and conservation of important estuarine ecosystems for decades, starting with the Salmon River estuary in 1978. Our efforts have largely focused on the purchase of land or working with partner agencies to seek other protection designations. The Comox Slough in 1975, the Nanoose Estuary in 1977, and the Salmon River Estuary in 78. And we're continuing with this acquisition and securement all the way through today. And since these early securements by Nature Trust of these estuary ecosystems, Nature Trust and partners have secured or designated over 110 sites or 12,000 hectares in the West Coast region. And 80% of these are estuaries or foreshore areas. And so as a conservation and land management organization, we're always interested in the ecological health of our conservation lands, identifying threats and opportunities early. And we have a keen interest in best directing our limited resources in terms of funds and labor to protect and preserve ecosystems that will be resilient and flourish in perpetuity. Sorry about that. So like most organizations, there's always a process of assessing whether management efforts and resources are being best utilized to support our overall conservation mandate. So for many of these coastal lowland and estuarine areas with continued threats to coastal conversion and climate change, we want to determine whether our management supports our overall goals. So key management questions, are these conservation lands going to survive and thrive? Are they resilient to things like sea level rise? Are we making best use of our limited resources, and are we looking forward enough in terms of our conservation? So with these questions in mind, we sought out a good monitoring framework for these estuaries. And And we found one that was developed by the National Estuarine Research Reserve Association in the States. It's called the Marsh Resilience to Sea Level Rise tool, or the MARS tool. And that had been implemented in 2016 along the Pacific and Atlantic coast of the US. And so we thought that, our ongoing monitoring and adaptive maintenance strategy could really build this in to get a good idea of what's happening in the estuaries that we manage. So in 2019, we received funding through the BC Salmon Restoration and Innovation Fund, and began this 5-year, now going on 7-year study at these estuaries you see here. So we started with 15 sites across the coast of British Columbia, and we've since then expanded it to 20 different estuaries along the coast. So our project goals, just briefly, the big goal was to develop meaningful and lasting partnerships between coastal First Nations, our organization, and other project partners to conduct this monitoring and research to assess estuary resilience to sea level rise on Vancouver Island, the Central Coast, and Haida Gwaii, to implement several major ecological restoration projects utilizing the data collected to try to enhance resilience at some of these sites. And I'll be going over some of those today. And just increase the knowledge and capacity of all our partners to make informed management, conservation, restoration, and enhancement decisions, as well as to showcase the integration of science and cultural knowledge and heritage of our First Nation partners. This is similar to a slide that you saw John present. The strength of our project is built on these strong partnerships with coastal First Nations, non-governmental organizations, provincial and federal governments, and academic groups. So there's a big splash of all the different logos of our involved partner groups. We have monitoring partnerships with 15 different coastal First Nations. And Indigenous community partnerships are critical for our project success, where all knowledge sources are respected and acknowledged in project planning and implementation. And there's really this sense of place-based environmental stewardship. Just getting a bit into the monitoring methods. The MARS tool, or the Marsh Resilience to Sea Level Rise tool, is a multi-metric index which incorporates 10 quantitative metrics, which are grouped into these 6 resilience categories. So you can kind of think of the resilience categories as different aspects or characteristics which influence ability to be resilient to rising sea levels. And at its core, the MARS tool measures an estuary's ability to trap sediment from upriver and increase the elevation or grow its marsh platform comparatively to the rate of projected sea level rise. So, we have a bunch of monitoring instruments out in each estuary that are collecting these data. The MARS index scores for each estuary provide guidance for land managers and decision makers on the type of management actions to take. In addition, the index scores inform decision-making for ecological restoration portions, as I just mentioned. So, for example, if you have a resilience score that's high, you would focus on preservation, secure additional lands that may not be designated as conservation lands, maintain the ecological integrity of these intact systems by reducing pollutants or removing invasive species, kind of just minor action focused on preservation. If the resilience score is moderate, you focus on methods to enhance that resilience through restoration. A really popular method to enhance that restoration right now in the United States that's showing really positive results is the addition of sediment through thin layer sediment placement to increase that marsh platform height. John touched on, improving connectivity through the removal of historic berms, dikes, anything restricting tidal influence, and enhancing connectivity to freshwater channels, that kind of stuff, and organic soil formation. And if the score is really low, then you want to be able to facilitate that desired transformation. So, as land managers and conservation organization, that may indicate to us, hey, it's time to identify and secure adjacent lands for conservation to allow for that eventual landward migration and reduce the pressure of coastal squeeze, remove barriers to the landward migration of these marshes. And so for the MAR scoring, basically this is just for the 15 sites that were included in the original 5-year study. But what we found was that 12 of the 15 sites exhibited characteristics that indicate moderate to moderate low resilience to projected sea level rise. And in some cases, depending on the geographic location along the coast, the effects of were either exacerbated by crustal movement of the Earth crust, or they were mitigated by it. So we found, for instance, with Haida Gwaii, the landmass is actually dropping. The crustal movement is decreasing, so it's exacerbating the effects of sea level rise. So, in essence, there's lots of room to improve the situation. Takeaway. So as I mentioned, we're using these MARS outputs to, so with a site that's moderate low, we'd be looking to enhance the resilience of these sites. In addition to the MARS outputs, we did a big process of restoration project planning using a multi-factor matrix-based approach to evaluate and rank potential restoration projects. Included qualitative and quantitative measures, partner input, and expert opinion. And so I'm just going to get into some slides that kind of show some restoration projects we undertook as a part of this project. So in the Namick Estuary, the Nanaimo River Estuary, working with the Namick First Nation in 2022, we undertook a major restoration project to increase freshwater and sediment distribution to the eastern and central portion of the estuary. What we found was, because of this bifurcation in the lower river, and due to historical gravel extraction activities in the western channel, there had been changes to the flow dynamics of the river, and there had been this increased bedload deposition in the eastern channel, whereas most of the fresh water used to flow out of that central channel there. And so we worked through a process with the nation and with a consultant to basically excavate a new channel through the gravel bar. Oh shoot, I think my slides are out of order here. So we excavated a new 350-meter long channel by 14-meter wide through that existing gravel bar, which basically increased the freshwater flow to that central portion of the estuary by just over 100%, allowing that freshwater to basically provide nutrients and sediment to that somewhat sediment-starved portion of the central marsh area. So I'm just going to, sorry, 1 second here. I'll come back to that based on my slide order. I'll come back to that project to show you the before and after. But a second project that we looked at was tidal channel reconnection in the Gwadzi or the Quatsi River estuary up near Port Hardy. We worked with the Kwagil First Nation to breach an old roadway that basically bisected that southeastern portion of the estuary near the Quatsizi River to reconnect tidal channels and improve tidal flushing. And I've got some photos of that. So this was completed in 2021, and of course we have effectiveness monitoring programs for all of these restoration projects. But basically, before it was enclosed with just the river, a small bridge over the river, and we installed a pedestrian footbridge along the old river the old road alignment, and then have a new tidal channel draining the estuary and marsh. And we did a bunch of planting there and have built some mid and lower bench habitat. So really reconnecting these isolated habitats for fish and wildlife use. And here we go. Here we're back to the Nanaimo. So here's a before and after. Kind of before, you can see how constricted the eastern channel was there. Nearing completion, just have a plug dam, and then afterwards showing the completed channel through the gravel bar there. And that was completed in 2022, and now we're monitoring for changes in sediment accretion rates and any changes in channel morphology. A third reconnection restoration project was in the Cusum, or the Salmon River estuary near Sayward. There's an old float plane causeway that juts out into the estuary that was kind of a barrier to tidal channel distribution of tidal waters there, and had some remnant ponds that were cut off from good flow there. So we introduced 2 breaches into that site, and then that's still used as a walking path. So we installed a footbridge again in that case. So before there was just a kind of a collapsed culvert, and then we opened that up and installed this pedestrian footbridge over top at 2 locations. And yeah, so we're focusing on the effectiveness monitoring and adaptive management at this site. And it's also, as a part of our partnership with John Moore's lab, they're doing a lot of the fish sampling, the juvenile salmon and fish sampling, looking at preferential habitat use within these areas. So this isn't direct estuary restoration, but it's restoration of a sand barrier spit at the Qualich, or the Englishman River estuary. So really focusing on the shoreline and coastal process restoration, focusing on those core abiotic drivers that really give rise to estuarine ecosystems. So trying to just undo the historical damage that's occurred. So this spit property, Nature Trust acquired, and over the last several years, we've been looking at restoring the seawall. So some before and after photos here. Basically removed roughly 600 meters of seawall now. And any improvements on the land, there was a bunch of houses, a house and outbuildings. About 1,000 cubic meters of concrete and rubble taken off the shoreline, because this previous homeowner had basically tried to use anything at their disposal to shore up the shoreline, and removed about 1,300 cubic meters of riprap from the site. So, it's been very interesting to just remove this shoreline armament and kind of re-expose the spit to these, the highly dynamic nature of these coastal processes at the mouth of the estuary, and see where the volume of the sand spit is being redistributed, because the main stem of the Englishman River is abutting the southern side of this spit now and redistributing everything. So it's a very active site in terms of its geomorphology, and we have a pretty comprehensive monitoring program set up there of cross sections and using remote monitoring to estimate volume, movement, and that kind of thing. And of course, it'll be very interesting to see what the influence of the spit dynamics is on the estuary marsh as well. So just thought I'd highlight that one. And then our ongoing project in the Cowichan estuary, it's a massive restoration project located in the southern half of the Cowichan estuary. It is it's I think the largest estuary restoration project on Vancouver Island that I know about, anyways. And it's multi-phased. Um, we're looking at increasing estuary resilience through the restoration of this lost estuary marsh that was farmed for the last 100 years through Western agricultural practice. And we're really focused on this Indigenous food revitalization component with Cowichan tribes. So it's received a lot of attention. It's kind of right at the interface of recognizing that First Nations forms of agriculture through their food systems, like it's just as valid as important as Western agriculture. So there's been a lot of that talk and discussion surrounding the project. So phase one of the project was focused on this smaller area that we call Coxsila Marsh. And this area had, in the late 80s, early 90s, a storm had naturally breached these earthen dikes that surround the site, this perimeter dike. So it was exposed to salt water just through a very narrow tidal opening, which contributed to, so all these little channel networks you see have formed naturally where remnant channels might have been before it was diked off. And in about mid 90s, DFO did a project where they opened it up on that western side there to freshwater flow from one of the Coxsila River distributary channels. But what we found was, that's still constricting a lot of the tidal and freshwater movement because of this remnant dike. So in the summer of 2023, we removed those red lines to indicate where we removed remnant berms, earthen berms, and just distributed the soil, redistributed it on site as sort of like a thin layer placement strategy, so we didn't have to truck anything anywhere. And then we increased the number of tidal openings. So this was in keeping with Greg Hood's work to try to increase tidal exchange and allow better access to the habitat through existing tidal channels. So that was completed in the summer of 23, this phase one. And phase two focuses on the much larger Cowichan Farm, or historically it was known as Dinsdale Farm, which is what you see in this green area right in the foreground here of the photo on the left. And so we're focusing on decommissioning of the dike surrounding Dinsdale Farm. It's a regulated dike under the Provincial Dike Management Act, so there has been a permit process for that. And so we've, in order to basically eliminate the transfer of flood risk, we've implemented various flood mitigation engineering features into the design. And the remnant tidal channel networks that we're going to excavate those and add to them to basically come into line with the criteria set out by Greg Hood's allometry equations for total length and number of tidal channel openings. So there's some, with the project, you can kind of see that's under a mean high tide. You can see the depth of inundation there in that width project on the very right. And so, yeah, that's going to restore roughly 100 acres of estuarine marsh in the Cowichan Estuary, 46 hectares or so. And yeah, just touching on the Indigenous food systems revitalization component. As I mentioned before, it's really acknowledging, getting away from this idea of fortress restoration, where it's restoration to a natural state in exclusion of people. It's acknowledging that these were managed landscapes in the past by First Nations people, and that's really what they're going to return to. That's kind of the ideal state. So, we're working closely with Cowichan Tribe staff, Jared Williams, Dr. Jennifer Grenz of the UBC Indigenous Ecology Lab to incorporate these elements of food system revitalization into the restoration project. So one thing we realized early on was that, with a project area this size, we are going to rely quite a bit, like similar to Zisaba, on spontaneous recolonization of estuarine plants, but there is going to be a big focus on incorporating traditional food and medicine species. So we quickly realized that no native plant nursery can supply these plants on the scale we need. So this past summer, we established a 4.5 hectare plant nursery on site to grow and propagate these species that were identified by Cowichan Tribes elders, um, and we worked with Satinflower Nurseries based out of Saanich to establish this nursery and get the plant stock in there. So we planted phase 1 of that project. You can see in that top right photo the planted rows that represents 1.5 hectares of the site, and that was planted in the fall of 2024. And we'll subsequently scale up the nursery using propagated plants and seed from that first set. And we actually have 1 additional hectare planned as phase 2 for this fall of 2025. So we've had lots of Cowichan Tribes engagement with that, lots of youth camps coming out to root camps to work and pull weeds and get connected with the land and discover what some of these species are. And so it's become an excellent education tool for Cowichan Tribes in working with their youth groups as well. So that project very much in process right now. And I'll just give one other quick example of land securement, where we secured 2 big parcels working with Tlowitsis First Nation to secure the Shoal Creek estuary and protect the existing marsh, as well as adjacent uplands in the valley, you can see on the right there, to facilitate that eventual landward migration of the marsh surface as sea levels rise. And just to touch on some key success, I've kind of mentioned them throughout the talk, but Indigenous community partnerships are obviously the #1 biggest key to success. All knowledge sources are respected and acknowledged in the project throughout planning, decision-making, and onwards. Place-based environmental stewardship and the recognition of interconnectedness of all these species, as well as this, this concept of losing this concept of this fortress restoration. Partnerships, interconnecting, so each person can play on their strengths, environmental non-governmental organizations, academic institutions, to provide that real scientific backbone and this kind of hypothesis-based monitoring, as Greg mentioned. And a third thing is obviously stable and consistent funding, ongoing resources for monitoring and adaptive management of these projects. They're quite big in scope and quite cost heavy up front, but also to build in that consistent funding moving through adaptive management phase and onwards. Using assessment tools that are easily scalable across a broad landscape. That's in essence what the MARS tool was. It was quite easily scalable to implement at different sites. And we've been increasing the number of sites that are a part of that network, on an ongoing basis. And then encouraging linkages and opportunities to support other concurrent research activities, which I didn't really get into, but there's a whole bunch of other things that were tied into. John Moore's work with juvenile salmonids. There's a big blue carbon initiative looking at the carbon storage abilities of these estuarine ecosystems, as well as just water quality initiatives and tracking and monitoring of different physical parameters of estuarine waters. So I'll leave it at that. So on to the questions. Thanks.
Great. Thank you so much, Steve, for that great talk that I think was like just the perfect wrap up for our group of morning speakers, where you presented such a variety of case studies that applied some of the tools that earlier speakers this morning have introduced us to. And you've also planted the seed around blue carbon and there's a few other things that you planted in there that will be reconnected by afternoon speakers. So this was just a great wrap up for morning. I'll give a heads up to our panel members that we'll go to a panel discussion shortly, but first deal with a couple of questions that we've had come in through the Slido for Steve's talk. And I noticed when you talked about the Cowichan project in particular and the mention about dikes and flood mitigation, the Slido chatter got very active, and I think that's where I'll start, because I recognize that that idea of increasing connectivity in an estuary often comes with the challenge of reconciling the need to protect infrastructure and land, and how with that Cowichan project, could you speak to some of the flood mitigation features of that project that satisfied those dike requirements? And there was another question that I'll sort of bring into that around, well, if it was a farm land that was a decommissioned farmland, what was the need to continue to provide that flood protection in the first place? So if you just want to expand on that, it'd be great.
Sure. Yeah. So the flood mitigation features. Basically, I'll preface this by saying I'm a restoration biologist, not an engineer. So we have obviously an engineering firm that is working through the all of the flood mitigation design, detailed design. But basically, the dike decommissioning permit is enabled by really detailed hydrological modeling of the area to basically assess the extent of flood protection of the existing dike, and then so it's modeled basically in a condition with the dike, and then in a condition without the dike, and then the mitigation features are designed to address any areas where there's a change in flood protection from the baseline with dike. So in particular with the Cowichan project, there were a couple areas where in a high tide with like a storm surge scenario with wave run up, there might be run up towards Cowichan Bay Road. So there are some mitigation structures that come out into the field to basically stop any wave run up, things like that. So, and then another mitigation feature was right along Cowichan Bay Road. It's an elevation tie-in feature that is basically the same elevation as Cowichan Bay Road, but it incorporates a swale and a drainage feature down to the southern distributary channel of the Coxsackie River to improve any overland movement of water from that distributary channel across Cowichan Bay Road.
Okay, appreciate you elaborating with some of those additional details. Looking to the Slido, we've got lots of votes for a number of questions. So I'll pick one here with the idea of a lot of the projects that you discussed involve the removal of materials. In some cases, you mentioned that the reuse, the repurpose of those materials is sort of that thin layer placement, but in other cases, you may have needed to remove those materials off site. So could you speak to some of how you dealt with the cost to that? Were there opportunities to recycle, reuse, thin layer placement, I suppose, being one of those opportunities, and contaminants, which is so often a common issue in estuaries? Did you have to deal with that, and if so, how?
Yeah, that's a great question. So we vastly prefer to reuse materials on site, and quite often, with a habitat connectivity project, such as like these removal of these historical berms or dikes, earthen dikes, quite often those were constructed by material that was taken from on site. So like we did a huge, I didn't talk about this portion of the restoration project, but in the Nanaimo River Estuary, we removed approximately 2 kilometers of these earthen berms, but that material had been excavated right basically a trench was excavated, and then the material was side cast into a berm. So, it was able to be redistributed on site, which removes any trucking cost. It basically helps contribute to, like, in addition to the removal of the dike helping the connectivity of the landscape, it also does lend itself to this thin layer placement concept of building up the marsh surface a little bit through this, as long as it's spread and side cast, at a reasonable depth that the vegetation can quickly grow through it. So we vastly prefer to reuse on site. With projects like the Nanaimo River Gravel Bar project, where we excavated that channel, that material we partnered with Lafarge as well as the Nanaimo First Nation, and so to manage the cost, Lafarge, which is they're a local gravel, basically a gravel extraction company that operates elsewhere in the valley here. We partnered with them, and they provided the trucking costs as kind of like a goodwill effort to to help with things out, and they want to be a good steward and partner in the area here. And so approximately half of they truck that material to their pit in Cassidy, nearby, south of Nanaimo, and then about half of it was earmarked for beneficial reuse elsewhere in the watershed for Snamuk's concurrent restoration projects for side channels and spawning habitat, basically, because it's prime gravels, right? So anywhere where you can seek to involve basically corporate involvement of local players, that really helps. And I found, as a as an NGO, a not-for-profit, they if you just approach people and discuss it, quite often they're receptive to chipping in something like that.